Hi, Diego. Howdy, you two.
Single theme, and we will afterwards have a discussion session and questions, and then we're going to go out to our big hoop house where we have our worm bins, and we'll show you the ingredients. Go into worm bins, and we'll even let you touch our worm castings, which you may not think is a big deal, but wait till you touch them. So it will be a bit muddy out there. Hopefully everybody's dressed appropriately and watch your step. I want to point out something here, which is this flyer. I don't know, Matt, if you brought any.
I passed out the one that I had.
Okay, so it's just an announcement of one of the things we're up to here in collusion with Matt, and with that I'm going to have Matt give a little presentation on, also there's these little pink slips announcing his event, so if you get a chance, pick up one of those. So, thank you.
Hi, my name is Matt Great. I am co-owner of Delphi Farms. We were at Farmers Market for 10 years. I've been following Gary and Albright's theory on farming for 15 years now. We've read over 50 books on the subject of farming, soil fertility, crop, everything. And when we became grandparents, we stopped going to the market and pretty much stopped working the farm. We've got 2 acres of garden land that we donated to the charity I founded, which is AFAB World Charity. It stands for Americans for a Better World Through Peace and Education. And the focus on this charity is to bring the technology we all have in America, eventually one day, to the people who are living in Stone Age technology on sustainable living, and especially agriculture. Because if you can teach people sustainable agriculture, you can cure disease. It just won't happen anymore because they're eating balanced foods. And that's how you heal the world. So anyways, locally, we have the 2 acres donated to us, and we're growing food for the food bank. We donated to the food bank, and we've started a education opportunity volunteer where you can come, I think probably Saturdays for 2 hours, and we'll do some garden work, and I'll share the knowledge I've gained over the last 15 years in sustainable agriculture. So that's why I wanted to show everybody the flyer. The first project is about the garden, and then the second project is a collaborative that I'm working with Gary on the garden boxes. Have you told him all about that?
I hadn't, no.
Well, I'll let Gary tell you about this exciting new program we're doing with the community. And I just wanted to let you know that that's the opportunity that will probably be available about the time this class ends, if anybody's interested in coming out and helping.
Okay, if the creek don't rise, where it's going, it's rising.
Oh, I got Sandy Loam on a hill.
Oh, okay.
I got no rising problems.
But I don't want to get you too excited, but we do have some projects going on that we haven't said much about. And one of them is setting up new community gardens around the community, mainly in Lacey. And we want to put a demonstration raised bed box with our superior garden soil in it on each of these sites, and have people plant them and compare them to garden plots that don't have what we think of as high a quality of soil with the right fertilization, so they can see for themselves. But I could go on and on about that, and I won't. So remember that we have another lecture on building soils, and we have a workshop, the final class. So all of you who have attended these, and we're going to say if you've attended all of them or you have some really good excuse, following the workshop, we will be issuing a certificate of Master Soil Builder. So you'll want to stay around for that. The other thing is that the workshop is free for those who have faithfully attended. So there's no charge on that last class or workshop. Alrighty, I'll get into my talk for the day, which is on vermiculture, earthworms, and castings. So, do we have another person that's going to be sitting in? No. No, I guess not. Oh, we do? I'll go ahead.
What's that?
Vermiculture, or the raising and management of earthworms, probably seems like an odd topic to insert in a course on soil building. But when you realize that earthworms are the original soil builders on a truly grand scale, and that they can be employed to build superb soil for you, and for nearly everyone who knows how to cultivate them, you see the clear connection and the advantages. What earthworms and castings do and can do toward the development of a perfect soil for growing superior plants and food crops is nothing short of astonishing. The prospects for capitalizing on what they do to raise the quality of your garden soil and its produce fully warrants a whole class on the subject, and warrants understanding all you can learn about worms and their manure, known as castings.
Sorry, man.
Okay. Have a seat. There's one there, I guess.
Want me to get another chair?
No, she's fine.
Is it just you?
There's one more. Okay.
Oh, okay. Uh-oh, we may need another chair. There is one in the second row here. If you want to sit more front and center, there's one here.
Yeah, I want to sit here.
Okay. Okay, only a small part of the planet's land area, amounting to 4 billion acres, is farmable. And while the fertility and productivity of that land is deteriorating and shrinking in size, the world's population continues to rise and currently stands at over 6 billion. The statistics of this trend are very scary. We have run out of new land to exploit and are faced with having to upgrade and restore what is left by and large. This is where the earthworm and its castings come in and offer surprising promise if we know how to cultivate the worms and develop methods for intensive vermiculture. Few people realize that the earthworm is largely responsible for creating the world's topsoil. However, just as the world's soils vary widely in their depth, fertility, and productivity, so do the soils vary in their suitability as natural habitat for one or another of the many species of earthworms, so they require different kinds of habitats. Thus, their numbers or density will vary greatly, and so does their present contribution to the amount and quality of soils for the growth of plants or crops. However, the possibility for raising the productivity of nearly any soil to a high level anywhere, and doing so relatively inexpensively, and I should have said quickly, exists through proper vermiculture practices. Commercially made worm castings are prized as a high-quality soil amendment and tend to be used sparingly. On the other hand, home-scale worm raising for kitchen scrap disposal has become quite popular, although it tends to generate only small quantities of worm castings or the less pure and incompletely processed vermicompost from small worm bins. And I suspect most of you are familiar with Appelhoff's book, Worms Eat My Garbage. And that's about, you know, kind of indoor, small scale, kitchen garbage type vermiculture. It's a good book, but I'm not going to be going into that aspect of it so much as I am how to deal with this on a bigger scale. And so that's kind of what we'll be talking about and showing today, and hopefully you can figure out how to adapt it to your purposes. Okay, as a rule, neither commercial nor home-produced castings will incorporate actual soil. In fact, the usual advice is to avoid it. Some gardeners will generate large numbers of redworms in cold-processed compost piles, but usually not a lot of castings or castings of particularly high quality. In other words, they're sort of accidental. The quality of worm castings will depend primarily on what the worms are fed. At Black Lake Organic, we've developed a method or a system of making quality castings on a fairly large scale and employing actual soil, aka dirt, as one component. The system we use is a variation of perhaps the earliest developed method of intensive worm culture called the Earthmaster system. It was developed in California in the 1930s by Dr. Thomas J. Barrett and actually was made famous by use of the method throughout his homestead for what he referred to as biological soil building. Our method, however, goes beyond Dr. Barrett's in that we incorporate supplemental mineralization to make the castings extra nutrient rich. Apparently never occurred to him. I had looked into worm raising and experimenting with it many years ago, but somehow managed to overlook Dr. Barrett's method with its focus on soil building rather than raising earthworms for the worms themselves and selling them, which Dr. Barrett regarded as unethical. Actually, now that I think back on it, I had encountered a book on the Earthmaster system way back in the 1970s and devoured it. I was intensely excited about what it represented in terms of self-sufficiency, lifestyle plan, but probably not fully appreciating its deep significance and uniqueness. It was a library book. Over time, my memory of it faded. My reawakening and reacquaintance and subsequent inspiration came on the night of October 1st, 2008, when I picked up the incredible little book, Harnessing the Earthworm, written by Dr. Barrett in 1947 and revised in 1959. This is the book here. It says so later on that I advise everybody to get it and read it. One of the places you can find it is in Acres USA catalog, and you can simply go to, I believe it's acresusa.com. And you can learn more about it. There's an incredible variety of books available from that outfit. Okay, the subtitle of Harnessing the Earthworm is How to Let Earthworms Work for You to Build and Condition Your Soil for Better Plants, More Beautiful Gardens, and Richer Crops. It is a profound and intriguing work, very well written, and I would encourage everyone to read it. Other books on worm raising, with their focus on production of the worms for marketing, employed rather complicated systems involving separate feeding and bedding media that had to be fussed with on set schedules. He combines the bedding and the media, and there is really no fussing. By contrast, Barrett's system is simple and sensible. You simply layer in the feedstock ingredients in your cultivation bins. It can actually be done outside without a bin. Add worms and let them do all the work until 3 or 4 months later, when it has all been converted to castings, and you retrieve the beautiful homogeneous black gold. And wait till you get out there and put your fingers in it. You're going to want to eat it. In the meantime, all you do is keep the bed watered, add a little chicken feed to the top, and keep the bin covered. They like darkness. They hate daylight. The worms will be concentrated near the top. You remove them and use some or all of them to start new bins. The one caveat is to guard against extreme heat and cold, which can kill them, as we found out in the winter of 2009. These are superior castings that we're making. The way we use them is as an ingredient in our premium potting mixes for both indoor and outdoor versions, and in raised bed garden soil, which we also will be making. Following today's lecture and discussion session, we'll go out to our large hoop house and show you the cinder block bins we use and explain the feedstock ingredients. Then in our 5th class or workshop, we plan to demonstrate the bed preparation, as well as how we make our potting and gardening soil mixes that include worm castings. So now I want to back up and quote some excerpts from Barrett's book that I find powerful and provocative. And there will be some repetition of points I've already made or that I'm going to be making later, which I hope you can excuse because I couldn't figure out a way to avoid them. The first one comes from the introduction by Lady Eve Balfour. Lady Eve Balfour, the English woman organic farmer and disciple of Sir Albert Howard, who I mentioned was really the grandfather of organic gardening, at least modern organic gardening and composting, around 1946 wrote the introduction to Harnessing the Earthworm by Dr. Barrett, who then resided in California. In her introduction, Eve Balfour noted that as many as 2 million earthworms per acre were found in the Nile Valley, and elsewhere 3 million had been recorded on some farms. Furthermore, the earthworm was known to consume and excrete its own body weight in soil every 24 hours. The earthworm is one of the few creatures that eats its way through its environment, the soil in which it dwells. This is what she said on pages Roman numeral 14 through 16. Since earthworm castings are composed largely of colloidal soluble humus and are far richer in available plant foods than the surrounding soil, this represents a staggering annual deposit of natural fertilizer quite apart from the continual addition of the dead bodies of the worms themselves as they fulfill their own life cycle. Now, I talked earlier about colloids being minute clay and humus particles. Note the word available that she used. How the soil could be far richer coming out of the earthworm than it was going in is explained by its being ground up and processed by the worm's internal chemistry to release minerals and other nutrients that previously had been locked up or unavailable in the soil for plants to use. Citing the wanton destruction and degradation of farmable land over the centuries, Balfour goes on to say, mankind is at a last frontier. There is no new soil to be had in the horizontal plane. His hope lies in building new soil vertically. In other words, she's saying that to make up for the loss and deterioration of farmable soils, which is really scandalous, there are books on that subject that I won't go into, and in the face of our ever-increasing human population, it will be necessary to raise the productivity and fertility of each available acre or garden through the intensive cultivation and propagation of earthworms or through vermiculture. There are some other ways, a few. According to Balfour, a major crisis of prospective starvation faces the human race. My own view is that it's more a matter of malnutrition than of starvation. Citing a previous publication by Dr. Barrett, Balfour states, Dr. Barrett sums up the matter thus: the problem facing civilization today is rebuilding the soil and restoring the earth to a form immediately usable for food production. By the slow process of nature, it takes 500 to 1,000 years to lay down an inch of topsoil. Under favorable conditions, a task force of earthworms can do the same job in 5 years. Employing other methods, we could probably cut that at least in half. You get it closer to in 1 year. Do what takes nature 500 to 1,000 years to do. Since this obviously hasn't happened and isn't happening everywhere under existing conditions, natural or otherwise, one has to ask what those favorable conditions Barrett refers to will be. The answer comes down largely to food. This whole thing of soil building is about food, and the admonition of Barrett and Balfour is simply to feed earthworms. But I point out the qualification of proper or right food. According to Barrett, earthworms are soil builders. Everything else, plant, animal, man, and bacteria, are food for earthworms, whose function is to mix living or organic matter with mineral particles and send them forth on their round once again. Thus, earthworms are the original master soil builders. I would take it further than Barrett did by also supplying minerals in the form of rock powders. The idea here is to combine remineralization with vermiculture and with humus manufacture by the worms. The earthworm is the original mineral-augmented organic fertility synthesizer. And my idea is to take this method to even higher levels by taking advantage of the earthworm's free processing machinery, supplying it abundant minerals to be forcibly ingested and made highly available and therefore usable in combination and intermixed with organic matter. Instantly turned to humus into a perfect size, cake crumb textured, superb growing media. As I said, wait until you put your fingers into our mineral augmented soil based castings. There goes the memory. Pam.
Yes,
Yeah, welcome Pam.
thank you.
All right. So the next step is relating this to your personal needs and situation, or to that of your family in a time when it has become obvious that the quality of store-bought food has and will continue to decline, while food prices at the supermarket are inevitably going to go up and up. Knowing how to get the most in nutrition and productiveness from your personal garden in light of all of this becomes serious business. And in fact, for mankind, the foremost concern, nuclear meltdowns to the contrary, is the growing of food for our sustenance. I guess that assumes that we've got air and water. Hi there.
Sorry.
Oh,
Sorry.
yeah. Somehow we're going to have to get you the earlier parts of this and make copies or something.
Well, it's our own fault.
We'll look on YouTube.
Well, you could do that too. Hey, oh, Matt left. Did you find them already? I don't know how you'll get access to them, but maybe he's going to put them on there. Sure.
Okay.
All right. The use of worms to process wastes and turn them into resources, and the use of extra rich worm castings adds an extra dimension of assurance and enrichment above what ordinary organic gardening offers. Whether it is with a kitchen scrap worm bin or a large worm cultivation bin that is specially fed, I would urge you to go into vermiculture in preference to composting and on top of your regular gardening practice. There are many bonuses to doing so for your vegetable garden, your fruit orchard, and throughout your landscape plantings. Properly produced with correct feeding, the manure or castings of earthworms can be the ultimate in fertilization and conditioning of soils for growing the healthiest, most nourishing, and most trouble-free plants imaginable. And speaking of trouble-free plants, I spoke earlier of the idea of nutritional pest control, and I since have come up across a short discussion on that topic that I've included in the handout I gave you, and it expands somewhat on that concept. Now, ladies, I don't know if do we have additional copies of those handouts? But if not, we're going to have to make them for you or something. Well, you can't.
That's okay.
On there?
We'll have to make them later. Okay. Properly produced with correct feeding, the manure of or castings of earthworms can be the ultimate in fertilization and conditioning of soils for growing the healthiest, most nourishing, and most trouble-free plants imaginable. I already said that. The next excerpt is quotations from Charles Darwin, the great biologist, which are needed to convey the grand scale of the earthworm's role in soil building as only Darwin could express it. In 1859, Charles Darwin's Origin of the Species about evolution was published. It shook and forever changed Western civilization. But Darwin was anxious to get beyond that and return to his lifelong passion, and study of earthworms. It was 22 years later, in 1881, when his book, The Formation of Vegetable Mold Through the Action of Earthworms with Observations on Their Habits, was released. Darwin regarded it as his more important book, more important than Origin of the Species. A fetish of earthworms? One has to wonder why that was so. Rather than being about earthworms, however, Darwin's latter book, and I haven't read it, is about vegetable mold, which was the term for topsoil, resulting from the worm's manure or castings. This is our clue. Darwin's very high regard for the earthworm's role in the creation of topsoil, upon which essentially all life, at least life on land, is totally dependent, and from which our own sustenance is derived, either directly or indirectly, is entirely warranted. It's hard to think of anything more important than the source of our food. And it might be that without earthworms there would be no topsoil. In the introduction to his 1881 book, Darwin stated in regard to his studies, "I was led to conclude that all the vegetable mold over the whole country has passed many times through and will again pass many times through the intestinal canals of worms. Hence the term animal mold would be in some respects more appropriate than that commonly used vegetable mold." Nobody uses that term anymore. That quote and those that follow comes out of Harnessing the Earthworm. And Darwin writes, "In many parts of England, a weight of more than 10 tons of dry earth annually passes through worm bodies and is brought to the surface on each acre of land, so that the whole surface bed of vegetable mold passes through their bodies in the course of every few years." In other words, all that topsoil out there over the course of a few years gets totally recycled through the earthworm. And basically, that's a big part of why it's there, how it came about. And you might look at it as that's their job. They do a very impressive job in the creation of soil, or at least topsoil that we grow in. Okay, from the collapsing of the old burrows, the mold is in constant slow movement. He means it gets moved. And the particles composing it are thus rubbed together. By these means, fresh surfaces are continually exposed to the action of the carbonic acid in the soil and the humus acids, which appear to be still more efficient in the decomposition of rocks. So you get the carbonic acid, which is basically carbon dioxide out of the atmosphere, or as a result of organic matter decomposition combined with water. Makes a weak form of acid, carbonic acid. Humic acids, very complex things, possibly very powerful, in spite of what they seem like they would be, come out of organic matter, decomposed organic matter. So worms prepare the ground in an excellent manner, this is going back to what he said, for the growth of fibrous rooted plants and for seedlings of all kinds. They periodically expose the mold to the air and sift it so that no stones larger than the particles which they can swallow are left in it. They mingle the whole intimately together like a gardener who prepares fine soil for his choicest plants. In this state it is well fitted to retain moisture and to absorb all soluble substances, as well as for the process of nitrification, which means the making of nitrogen fertilizer. The leaves, which are dragged into the burrows as food after being torn into the finest shreds, partially digested and saturated with the intestinal and urinary secretions, are commingled with much earth. This earth forms the dark-colored rich humus which almost everywhere covers the surface of the land with a fairly defined layer or mantle. So, this is me speaking now. Here it's necessary for me to interject an observation, which is that both Darwin and Barrett seem to use the terms castings, humus, and topsoil interchangeably to mean the same thing. causing much confusion for me because I don't think of them as being one and the same. I see lots of problems in understanding soils if the precise meanings are not clarified. Not all humus is worm castings. Castings are composed of both humus and earth, or what is mostly mineral matter. Most topsoil does not give the appearance of being castings. And if humus is a form of organic matter and an ideal soil, or even a typical topsoil, as we showed in that chart, that pie chart last week, contains only 5% organic matter, it's hard to see how topsoil or even castings can be equated with humus, since they mostly consist of mineral and inorganic matter. Now, several references have been made to humus being derived from minerals, which can't be entirely correct. Minerals are involved, but organic matter couldn't be derived mainly from inorganic matter or rock minerals. And I showed that on that one colorful chart, although you probably didn't see the percentages. But perhaps it was on one of the other visuals, that in rock there's very, very little, if any, nitrogen. If you were to take a rock and grind it up and analyze it, very, very little carbon, which of course are key to creating organic matter. Therefore, how could it come out of the rock? There is a lot of oxygen in the rock, but the oxygen is fused with silicon and silicon and aluminum, possibly other things. And the other more or less indispensable ingredient in an organic molecule is hydrogen. A small amount in the air, I think a very tiny amount in the soil. When you consider the organic matter, and not thinking about where it came from that is in the soil, yes, when you analyze that, you will find that there's carbon and nitrogen and oxygen, and maybe hydrogen. And that will vary a lot with the conditions and the fertility of the particular soil that you might be sampling. When you send it into a lab, they don't evaluate or measure carbon. They may not evaluate nitrogen, as we discussed earlier before the class got going. And one of the reasons is at least the carbon and the oxygen and the hydrogen and oxygen in water being one form is considered free. So why would you fertilize with something that's free? All right. So returning to Darwin's profound insight, here's what he said in summary. When we behold a wide turf-covered expanse, we should remember that its smoothness, on which much of the beauty depends, or its beauty depends, is mainly due to all of the inequalities having been slowly leveled by worms. It is a marvelous reflection that the whole of the superficial mold over any such expanse has passed and will again pass every few years through the bodies of worms. The plow is one of the most ancient and most valuable of man's inventions, but long before he existed, the land was in fact regularly plowed and still continues to be plowed by earthworms. It may be doubted whether there are many other animals which have played so important a part in the history of the world as have these lowly organized creatures. Barrett's book is essentially about accelerated topsoil building and restoration by bringing up subsoil and mixing it with organic matter, using worms as the excavators, mixers, and transporters. Speaking of the nightcrawler, here's what Barrett says. It quite generally burrows to a depth of 5 or 6 feet, and earthworm burrows have even been found at depths of from 10 to 14 feet. From these deep burrows into the subsoil, the earthworm returns to the surface, bringing new mineral parent material for topsoil and depositing it in the form of castings. Now, it should be noted, however, that the notion that substantial quantities of subsoil are brought to the surface is challenged by some researchers. In contrast to the deep burrowing of the nightcrawler, the redworm, which is most used in vermiculture operations and home composting bins, seldom burrows beyond a foot deep, and much prefers to live in manure piles or other high organic matter circumstances, such as kitchen scraps, where it can proliferate into extremely high populations when the conditions are right. Another name for the red worm or red wiggler is manure worm. There are some amazing things to know about earthworms. One is that it eats and therefore excretes its own weight in the soil daily. It has a very high feed conversion efficiency, whereas most livestock retains about 10% of their feed and excretes about 90% as manure. For the earthworm, it is the other way around. They retain 90% or build it into their bodies, which are very high in protein. Earthworms therefore make excellent food for your chickens and of course for the robins on your lawn. Yet the earthworm eats free dirt and essentially cheap or easily accessible waste materials and vegetation, and when it does, contributes its own nutrient-rich body to the soil. That 10% of their food the earthworm excretes is, or at least can be, the most exquisite of natural fertilizers. Depending on what's available for them to eat, or what they are fed, and particularly if they are fed supplemental minerals such as rock powders as we do here. Probably most of you have read the often cited figures that compared the surrounding soil from which they came to worm castings. Worm castings contain 5 times the available nitrogen, 7 times the phosphorus, 12 times the exchangeable potassium, 1.5 times the calcium, and 2 times the organic carbon as the soil around them. How they do this is mystifying until you realize that they are doing it. What they are doing is converting locked up or complex minerals and organic reserves into plant available nutrients. The figures that I just cited actually came from a single USDA study done on a Connecticut farm and a nearby woods in 1944, and the study is fully reported in Barrett's book. The farm belonged to Christopher Gallup, a correspondent of Barrett's, who was experimenting with ways to raise earthworm numbers through fertilization and soil treatment as a way to increase crop production. The 2 USDA investigators questioned whether the worms actually bring much topsoil up or subsoil up to the surface, and whether the worms were actually responsible for the observed differences in fertility or simply show up in more fertile soils. But the worm's contribution seemed totally obvious to Gallup and to Barrett, as it would have to Darwin, and it does to me. Several years prior to the 1944 study, Mr. Gallup had applied chemical fertilizers and lime to his land and managed to raise his non-hybrid corn production from 70 up to 80 bushels per acre. Following a few years after switching to manure and what he called earthworm tillage, as tilling down the debris from his crops that was left after harvest, his corn production reached 196 bushels, nearly a 250% increase. Just as significantly, a corn borer insect problem with which he had been plagued practically went away. There's nutritional pest control in operation. The earthworms, the more earthworms, the more crop production, Gallup believed. And as he described it, the worms swallow and digest both the decaying organic matter, and by the way, they don't like really raw stuff, organic matter, and they don't like fully decomposed organic matter. They want something that's just starting to turn rotten or rotting, and they may in fact actually be after their gourmet food is the bacteria and stuff that are growing on the rotting vegetation, and in fact are causing most of the rotting. So they are skimming that off, but also taking the organic matter with it, and this may be what they're actually seeking. So when you feed them, you don't want to feed them something that's you know, completely raw, although it won't take long before it isn't, or something that is fully broken down, and I'll explain where that is. So, he got this incredible production from using this method, and more or less propagating earthworms out in the open. The more oh, I already said that part. As he described it, the worms swallow and digest both the decaying organic matter and the soil itself, largely mineral materials, and leave behind tons per acre. Barrett cites up to 200 tons annually of nutrient-rich castings. The more earthworms produced, the more minerals processed and made available in combination with humus from the organic matter he harrowed into the upper 6 inches. In our case, however, we don't have to worry about whether the worms can get to the subsoil for retrieving stored minerals, or how much they bring up, because we supply abundant minerals plus soil. In effect, we force the worms to eat and process extra minerals. What we provide is every known mineral nutrient found on Earth. This is the same principle as we use in our bloom fertilizers, like here, mixes of mineral-augmented organics, which draw rave reviews and give excellent results in people's gardens and landscapes. Now we will ratchet that up using worm castings. The earthworm's role in intermixing and processing organic matter with minerals has changed my understanding and appreciation for what organic matter's contribution to fertility can be under the right conditions. It's the synergy. Earthworms in nature combine raw organic matter with soil minerals they swallow, and then convert this mixture into a super compost or humus-laden topsoil within just 24 hours. They literally create humus overnight. Other methods take a lot longer. It was Aristotle who described the earthworm as the intestines of the soil. The intestines of the earthworm act as a mini composting chamber, able to create superb compost without ever raising the temperature of the stuff above 100 degrees. They create a fully available concentrated plant food without destroying enzymes and vitamins already in the soil or created by microbial activity within the worm itself. Microbes, it must be acknowledged, are fully equal partners in the creation of soil and fertility. By contrast, well-made compost requires weeks or months to reach a humus state and passes through a phase of 130 to 160 degree temperatures, thereby destroying any enzymes and most vitamins, at least until it cools off, where it may no longer have enough usable food value to worms or for microbes. Worm castings supply or guarantee the essential biological activity needed in soils, although we also introduce friendly microbes in our worm feedstock, and it's the same ones we put in our bloom fertilizers. Castings then become a key ingredient in the potting and gardening soils mixes that we produce for sale. Because it is better stated and lends authority that I can't provide, I want to quote some statements from Barrett's book, attributed to a forestry professor, Heiberg, probably from the 1930s. If your soil is suitable for earthworms, there may be more than 2.5 million worms per acre, weighing about 1,400 pounds. That means that you may have more pounds of earthworms in your employment than all your domestic livestock put together. Certain molds or granular mixtures of mineral and organic material produced by earthworms give particular areas of the forest floor their whole character. Earthworms feed on soil, that is dirt, and organic matter, and thoroughly mixed soils in which they live. They move and enrich many tons of soil to the acre each year, and they thrive especially well in moderately acid and alkaline soils. Note that in their processing, earthworms tend to even out pH. into the neutral range, regardless of what you started with. Perhaps that's an exaggeration. One of the many indications of potentially productive soils is the presence of well-nourished earthworms. This last paragraph, I realized, I just discovered, actually came from the 1938 USD Yearbook Soils of Men. Arguably, the earthworm was the inventor and still the best practitioner of mineral augmented organics, a term that I coined back in 1998 to describe the combining and mixing of nutrient minerals with organic material to achieve optimum and balanced soil fertility. The concept is further developed in Black Lake Organics Gardening Information leaflet on Superior Soil Building, which I passed out in the first class. And if you didn't get that, I happen to have one here, and we can make more of that. Is there somebody that didn't get it? We'll need to make you one, but remind us. All right. Note, however, the quote above refers to well-nourished or well-fed earthworms. Where soils are lacking, we can provide organic matter and minerals and inoculate them with earthworms or worm egg casings that work better. And by the way, the worms that you raise are actually more adaptable to moving into new conditions than simply going out and gathering some worms from somewhere and moving them over here. Frequently they die. They don't adjust. So, we're talking about well-nourished and well-fed earthworms. Using earthworms or worm egg casings that have been bred and domesticated in worm culture beds, as we're doing here, to generate castings for use as a key component in superior potting and garden soil mixes. I've made a little diagram that shows the feedstock and layering method we are using and further describes it, and we'll further describe it when we get out to the bends later. So this is the diagram, and I'll just show it to you now, but maybe we can discuss it more when we get out back. These are 3 cinder blocks here, and this is the ground floor. So we start out with topsoil, sifted, and then we add minerals to it, and we add fine sand because, okay, the pink layer, topsoil plus minerals plus fine sand. We have a mineral mix that we use. They need small rock particles for their gizzards, and so this is a way of making sure that they can get those. The next layer is manure, which we want slightly aged, along with the litter that it usually comes in. And the third layer, the orange one, is peat moss, or we may be using dark bark instead. And then the fourth, the green, is vegetation, grass, leaves, kitchen scraps, coffee grounds, cardboard, wetted cardboard and ground up. Corrugated cardboard, mostly, or at least in years past, was glued together with a glue made from somehow melting down cow's horns and horse hooves. So that provided a proteinaceous food that the worms go after, and in the process they eat the cardboard too, which is made out of wood, basically. So those 4 layers, and then we repeat until we get to the top. Then we top it off with chicken feed and 10% lime mixed into that to give them a little extra feeding. I might as well mention that what you do is you make sure that that doesn't dry out, so you water them fairly frequently, and you keep the thing covered. And essentially that's it. You leave them to their thing. And in 3 or 4 months, all of this will be turned into one homogeneous thing. So I don't know if you combine pink, yellow, orange, and green, what you would get, but I think it comes out brown or black. And so that's what you get at the end, and I hope I remember to take that with me. All right, another interesting and instructive quote of the same Professor Heiberg occurs on page 24. In the mold, a main type of forest soil, the organic matter is intimately mixed with the upper few inches of the mineral soil. In its best form, it is crumbly, friable, and porous. It resembles a well-cultivated garden. Mixing is done by the soil fauna, especially by earthworms. Moles and insects also play a role or a part in this, which continually dig and cultivate and eat both the vegetable matter and the mineral soil. The excreta are placed on the soil surface. In fact, the entire humus layer of coarse mold consists of earthworm excreta. So that's what you find in the forest. With respect to productivity, the humus type coarse mold is undoubtedly the highest, and its ability to absorb moisture and thus prevent surface runoff and erosion is high. There is no doubt that earthworms are the most beneficial animals in forestry, and recall that Darwin regarded them as probably the most important animals on Earth, from the standpoint of supporting and sustaining everything else. The cultivation of the soil and plowing under of manure, which farmers and gardeners find to be of great importance for soil productivity, is done free by the earthworms, if they are furnished with a suitable environment. And of course, adequate food is a major part of that suitable environment. But the most spectacular demonstration of the earthworm's capacity for creating rich topsoil of excellent tilth occurs in the valley of the Nile River. The Nile River, at least before they dammed it, the Nile Valley is regarded as having probably the world's most fertile soils and the longest cultivated and seemingly being inexhaustible due to its annual flooding. This fertility is attributed to the unique confluence of the Nile's two main tributaries, the Blue Nile and the White Nile, carrying high loads of minerals from the highlands of Sudan on the east and organic debris from the forested lands of Abyssinia, Africa to the south, but also due to the churning of its humus-laden silt at the cataract of its confluence at Khartoum, and the subsequent conversion to premier topsoil by the lowly earthworm. The Egyptians understood what they owed to the earthworm, and the pharaohs made it a crime to kill them. So let me quote, or add a quote from Barrett himself. As the flood water spreads, the thirsty earth absorbs it quickly like a sponge, because of the earthworm burrows and other qualities, leaving its deposit of silt, that is small mineral particles plus organic matter. The earthworms begin their work, and almost overnight the silt is carried through the worms, digested, homogenized, and excreted as rich, fine, humus-laden topsoil loaded with immediately available water-soluble plant nutrients. Here no human cultivation is needed. The earthworms do the cultivating. According to Niall Brady, author of The Nature and Properties of Soils, as I mentioned, was one of the most highly regarded soils textbooks, soil fertility and soil processes are mostly associated with humus and clay particles, or colloids. I previously talked about how colloids kept cation minerals from being washed out of the soils. Brady states on page 18 that the best way to understand soils is as a biocolloidal entity, or a colloidal biological entity. I can think of no better, simpler way of combining humus and clay colloids in the most intimate fashion than having them go through the chemical processing and intermixing within earthworms that results in castings. Provided sufficient minerals are provided in their feed, this takes mineral-augmented organics to a much higher level of effectiveness in growing plants. So here is a summary statement by Brady, one of the world's foremost contemporary soil scientists, that also harks back to our discussions in the previous two classes. Clay and humus, the seat of soil activity. The dynamic nature of the finer particles of the soil, clay and humus, has been indicated in this book. Both these constituents exist in the colloidal state, wherein the individual particles are characterized by extremely small size, large surface area per unit of weight, and the presence of surface or electromagnetic charges to which ions and water are attracted. The chemical and physical properties of soils are controlled largely by clay and humus. They are centers of activity around which chemical reactions and nutrient exchanges occur. Furthermore, by attracting ions to their surfaces, they temporarily protect essential nutrients from leaching, and they then release them slowly for plant use. And actually, the plant roots take them as they need them. Because of their surface charges, they also act as contact bridges between larger particles, thus helping to maintain the stable granular structure which is so desirable in a porous, easily worked soil. On a weight basis, the humus colloids have greater nutrient and water holding capacity than does clay. However, clay is generally present in larger amounts, and its total contribution to the chemical, physical properties will usually equal that of humus. The best agricultural soils contain a balance of the properties of these two important soil constituents. So I'm nearly finished. The thing about worm castings is that they are of the perfect size and physical consistency, with very small particles held together in optimum sized soil pellets by the glue-like secretions of the earthworms and of its internal microbes, so as to resist rainwater's dissolving force, and having tiny air pockets and cavities where microbes can reside, and all of this adding up to an outstanding tilth and the perfect topsoil. Here is the key to restoring the earth on a broad basis, bringing back paradise, and simultaneously supplying the key component in the most nutrient-rich soils around the world for abundant, nutritious food crops and pastures, to sustainably farm and to feed our burgeoning human population, if we can get control of its growth. The main point of all of this is that the rapid creation of massive amounts of mineral-rich, humus-laden topsoil can occur in nature, but requires optimum conditions. However, we can duplicate or imitate those conditions almost anywhere, and through the intensive cultivation and feeding of earthworms, using comparatively abundant and cheap raw materials and waste products, generate garden soils and potting mixes of high fertility and excellent tilth. This is what Barrett would regard as conquering the vertical frontier to benefit mankind, but without doing damage to the earth and our environment, and even improving it in certain ways. The means or the way is there. I've found yet another way to save the world to whomever it may concern. So, that's the end of my presentation, and we can have questions and discussions. We're at 11 o'clock, and then we'll go out back and take a look at how we do this back there and what we use to do it with. Yes?
I've got a silly question. If you put pesticides in the ground, what does it do to worms?
Well, it'll depend on the pesticide, and there's argument over, for instance, whether or not ammonium sulfate, which is not a pesticide, it's a fertilizer, will kill earthworms, and probably up to after you get to a certain point it will. Albrecht and trying to think of his name, Brumfield, the author, that had the farms in Ohio, they used ammonium sulfate as a way of getting nitrogen and sulfur into the soil, although they were basically ecologically motivated and anti-pesticides. And probably the fact that they did that, insisted on doing that, caused a huge split or schism with J.I. Rodell, who was the head of the organic movement in the time. And he believed that there should be no artificial fertilizers used whatsoever, even if they might be harmless or beneficial, because they might be artificial. Well, ammonium sulfate would be. But as far as pesticides go, it will depend on the nature of the pesticide, I imagine. Some of them they may be able to process and neutralize, and some of them might kill them, and it'll depend on the concentration, no doubt, how much they're taking in. But microbes and probably earthworms are essentially our first line of defense and remediation, and mushrooms. Can't leave out mushrooms. When it comes to breaking down pesticides, microbes are quite good at it. There's all different kinds with different skills. Mushrooms and fungi perfecti, and Paul Stamets, who owns that company right over the hill here, has used mushrooms, demonstrated that mushrooms can kill up, clean up oil spills. And in fact, this may be going on in an unacknowledged major way in the Gulf now. I think he may have a big role in that. He is down there?
He's down trying to get him to wake up.
Well, okay, so he's still got this thing of, you've got to overcome this, but he demonstrated this. Department of Transportation held what amounted to a competition, pollution competition, whatever. And he, on an oil, not an oil spill, but an area that had been contaminated with oil, he sowed his oyster mushroom spawn, and I think covered it with plastic, and other companies were invited to come in and use whatever they do to clean it up. Nothing else worked. They went back, they lifted the plastic, all the oil was gone. There was nothing there but mushrooms. Which isn't to say you'd want to eat those mushrooms. But the point is they have that power. These lowly forms have the power to save the earth, if we wake up, right? If we start using them, and if we change our behavior a little.
So industrial farming uses pesticides and herbicides.
Unnecessarily. That's the interesting thing about it, but go ahead.
And fungicides.
Yeah.
For example, I came from San Joaquin Valley, where all this is being used all together all the time.
Yeah.
But there are no worms. I mean, there's very little.
Exactly.
And but is it mostly because the worms are not able to eat the microbes that really are the thing that they're after? And so those are the ones that got nailed, or is it because everything's out of whack?
I'll come back to that. Macy?
I remember reading an article many years ago, and it always stuck with me, that a researcher was asking that same question, and he went to a farm that was using industrial fertilizers and pesticides, and he watched the worms coming up, and their skin was blistering and cracking. And so when that happens, and of course the worm desiccates in the sun.
Right. So if you're dealing with people who refuse to acknowledge that the earthworm could have anything at all to do with soils, the condition of the soil, the workability of the soil, the fertility of the soil, the conversion of organic matter and minerals into nutrients and all of that stuff, and it doesn't count, doesn't matter, regardless. We're going to keep pouring the NPK on it, and if anything shows up in the way of a disease or a pest, we're going to spray the hell out of it with the most obnoxious, toxic stuff that we can find, because after all, we want to kill every one of them. It's a totally upside down way of approaching it. And what the answer is that it's a combination of things. Certainly the pesticides play a very direct role, but it's the whole system of farming, it's the whole mentality that ultimately destroys the soil. And someday we're going to wake up and say, hey, destroying the soil is not the best way to produce nutritious food. Yes.
Well, on that same vein, I read another article in Smithsonian years ago where they were, a fellow writing the article went to a strawberry farm in San Joaquin Valley. And you may have noticed the big, beautiful strawberries they have on the market now. Well, they've discovered that they build deep beds in the field, cover it with plastic, inject the soil with methyl bromide, which kills everything in the soil, and it's basically a fertilizer for the strawberries. Well, the strawberries do great, but the soil's dead.
They don't
and
do great.
They look great.
Well, they look, no, they
Yeah.
do
If
great
you,
for the
if
market.
you like cardboard, they're great.
Yes, exactly, they have
Exactly.
no flavor, they have no
Yeah, it's all
sweetness,
appearance, you
they-
know, and the American,
They're durable. You
the
can
American
hammer nuts
public
with
is
them.
partly responsible for this. They'd rather eat something that looks good than is good for you.
Yes, yes.
For the worm bins, do they have to have a specific spot in your yard where you don't want them to have too much sun or too much shade?
I don't think so, because as long as you're using a covering of these sorts of things, you know, and vegetation, it creates an optimum environment for them and for microbes. They can get out of the sun. It mellows the soil, keeps it moist, creates optimum conditions for the proliferation of the microbes, and for the earthworms, encourages them to come to the surface, or near the surface, but under the mulch.
Sure,
So, I think the short answer is no, it doesn't matter.
okay.
Yeah, Don.
How deep are each of these layers?
6 inches, I didn't point that out. This whole bin, you'll see it out there, is 2 feet high, and I'm sort of getting into the presentation out there. So each of these layers is about 6 inches, and the idea is we want roughly equal parts of all the 4 major ingredients. And the reason you don't go more than about 2 feet high is you start getting higher than that, and you create elevated temperatures. And you get them high enough, you kill the worms, chase the worms out, you kill the enzymes, destroy the vitamins. Yeah.
Yeah, 2 questions. Speaking of temperature, what is the best baseline or range of temperatures for your worm bin?
Oh, I forgot the rest of my speech. You know, ambient temperature, we have a problem in the hoop house in that it can overheat, but also you get into a severe winter and it can freeze so deeply that they can't escape it. You know, they go to the interior or go to the bottom, but if it's extremely cold, it'll still kill them. They get down around 32 or 30, they're goners. Because they're mostly, well, they aren't mostly water, they have a high amount of water in them. I can indirectly answer that in this other part of the speech, a few pages here, that I wanted to do on containers and container growing. And again, this is more about the conditions for container growing. Okay, the second part of today's class has to do with container media. Did I answer everybody's question there? Yes.
Can you put kelp as a medium in there?
Yes, excellent, yes, of course. Yeah.
Before I forget my second question, you said to throw on some chicken feed on top. Does it matter that much of the chicken feed out there is GMO?
I think that probably the GMO part doesn't matter. I mean, they're going to deconstruct it, right? So, and it's not going to be passed on to the plants, I don't think, because whatever genetics are in there are going to get broken down, disturbed, and furthermore, if it made it to the plants, it's doubtful it's going to make it to you. But yeah, there could be antibiotics and lots of other things in the chicken feed that you don't want. So you look for a natural feed that's as organic as you can find, if you define organic as absent toxic materials and so forth, as opposed to my definition. But the chicken feed that we used to sell here came close to being that, even though it wasn't technically organic. So you're looking for feeds that are made as much as possible with entirely natural, preferably organically grown grains and what have you. In this case, it was augmented with fish meal for certain essential amino acids or whatever those were for. Yeah.
Do you have any alternatives to chicken feed, or is that
Well, the books
number one
call for using
recommendation?
chicken mash, And I don't know that you can find chicken mash, so I figure chicken feed that has everything in it and as close to natural as you can get has got to be a good substitute.
So what are you looking for, the sugars in the corns?
It may be the sugars,
the wheat
it may be the protein,
and the protein in the fish
amino
meal?
acids and so on and so forth that are in that may or may not be in the other materials.
So alfalfa pellets
Alfalfa
would come
probably,
close to
sure.
the
Yeah.
nitrogen
Yeah,
and the sugars.
yeah. Those kinds of things, it's kind of giving them an extra snack. I mean, they probably don't have to have it, but they will come to the surface and they'll feed around the edges of it and underneath it to get the extra goodies. And here's a couple more
I've
questions.
got a question we used to raise rabbits and have and worms being the feces underneath it. We didn't put anything else in it.
Yeah.
What about if you had where your chickens are at, the manure went through and you had worms underneath there, or livestock, and so it went through grates?
Well, the manure worm, of course, likes manure. It likes cow manure. How well it does in chicken manure may be a different thing. And it may depend on the state of rotting. I don't know the answer to that very definitely.
Okay.
And yeah.
As far as getting too much organic matter in your soils,
Yeah.
how big of an issue is it, first of all? But then it seems like if organic farmers are always putting organic matter in there.
And this is the fallacy I've been fighting for years, using the biggest two-before I can get.
Well, what breaks it down? Is it the microorganism, or do earthworms break it down?
Well,
So-
you know, the organic matter is both broken down and built up. It's a complex thing that goes on, because as the microbes start decomposing it, each wave of microbes is replaced by another wave that's able to eat those microbes, and then another wave comes in that's able to eat those microbes, and you reach a point at which the ultimate last microbe has eaten everything else, and it's all gotten recycled and it gets built into their body. So when they die, there's really nothing left to eat them. Okay, so they have effectively locked up those nutrients, and they've locked it up in a really complex form, not a broken down form. And so it's in a complex carbohydrate, protein, who knows exactly. And this is one of the reasons probably that it's almost impossible to totally exhaust the organic matter in a soil. You get to the point where there's stuff there that can't decompose, at least on anything like a human time scale. So I'm probably getting off track here, and I've even forgotten what the question was.
Well, just the idea of getting too much organic matter.
Yeah, it does matter. Too much organic matters after you get past, say, about 10%. Because then you're starting to approach all organic matter, and the best thing for your plants is a combination of the two with really not very much organic matter. And one of the biggest mistakes in organic growing, commercial growing and so forth, is a sort of self-imposed ignorance of putting on blinders. Hey, all I got to do is go get a load of manure, or go cut the hay in my field next door and put it on my vegetable growing area. And this is counterproductive. After a certain point, you're actually degrading the soil, you're diluting the other nutrients, and take my word for it, it's a mistake. And so if you don't start with a professional soil test, or at least a good understanding of what your soil needs, and apply the appropriate minerals, you're never going to get there. You're never going to get that balance. And the more you throw something unbalanced on one side of the scale, the more it's going to go like this. So, I could talk about this for hours.
Sure.
But I have this rest of this to do.
Okay.
And so if there's another couple of quick questions, I do want to get through the rest of this. Okay, let me try this. Okay. The second part of today's class has to do with container media and growing. For situations where there is no available garden space and you want to grow some of your own food, or maybe some flowers or herbs handy to the kitchen, containers can be a solution and offer some flexibility in that they can be moved around and moved indoors or outdoors with the seasons. A first consideration is sunlight. Let's say you are in a second-story apartment with a balcony. You need to be on the south side or where your plants will get a minimum of 8 hours sunlight on good days. Secondly, the kind of container is a big factor. The kinds that breathe, such as terracotta and paper pulp, are best. However, they will take more frequent watering compared to plastic pots. Black plastic pots are the most durable compared to other colors, which tend to fall apart. However, the black plastic pots don't breathe and they soak up the most solar energy. Dark bodies soak up more solar energy. How much you have to water and how frequently will largely depend on how much organic matter is in the pot. Black plastic pots can overheat and kill the roots, the plant roots, which prefer to be on the cool side of near 70 degrees or 65 degrees, whereas the optimum air temperature is around 85 degrees. So the leaves and the stems like it warm, the roots like it fairly cool. When air temperature gets above about 100 degrees, most plants will shut down or wilt and may be killed, especially if their roots get hot and dry out. What you can do to retard the soil temperature is to place the black plastic pot inside a larger pulp pot. Another solution is to loosely wrap a sheet of corrugated cardboard, preferably white, around the pot and staple and clip it together. This knocks down the heat absorption. Another major consideration is pot size. The world of the potted plant is very different from the world of the unconstrained garden or landscape plant. Adjustments have to be made due to the confines of the pot. The smaller the container or pot, the greater the problem. When you get up to 10 gallons or more, it's less of a problem. For smaller pots, it simply does not work to use straight soil. As you water the pot, the soil compresses and squeezes out the air, so you need to offset that effect. If the plant should send out roots anyway as they grow and get bigger and thicker, they squish the soil and again squeeze out the air and prevent water absorption. When this happens, the roots die and the plant as a whole dies. The way you offset this compression effect is by mixing in aerator materials, which include such things as coarse sand, perlite, or pumice. To some extent, organic matter such as peat moss, compost, and aged manure help aerate or push apart mineral particles of the soil. But these also absorb water, as does the mineral material vermiculite. Vermiculite is a heat-exploded clay or mica that soaks up water and nutrients. Perlite and pumice are exploded lavas that mostly hold a little water on their surfaces but do not soak it up. So what you're trying to do with a potting mix is find a happy medium of opposites. And I've written a short article on that subject titled The Evolution of Potting Mixes, which I'll cover next week. The part that stupefies me is how many times I pick up a book on container gardening and it says almost nothing about container media or fertilizing. Sometimes it's one paragraph in the whole book, and usually the advice will be to buy just any commercial potting mix and feed with something like Peter's Liquid Chemical 5-10-7 or whatever. I guess it works in some sense, and maybe it's not terribly important for things like flowers. However, I can tell you that our BLO potting mixes and bloom fertilizers get rave reviews from Suzanne, my wife. Also, our vegetable starts and tomato plants, which we've sold over the years and which we're not doing this year, have long enjoyed a reputation of being the best in the area. It's the soil. Remember, what you choose to grow is not terribly important. Once you've got the soil right, in accordance with the materials and qualities I've been outlining, almost anything will grow very well in a pot or not. Well, you do have to make a special medium, particularly for smaller pots. So it's now getting close to 11:30, and I think the timing is about right. James, did I answer your second question?
Yes.
Okay. It's about time to truck out there and see what we're doing out back. And again, I hope we can make it up to the people who came in late in some way. If anybody, I have a couple copies extra of the soil sampling instructions, if anybody wants those. So they're up here. Fairly, I think it's as complete as it's going to get. End result, not as fully decomposed as I would hope. But this bed here is ready to be harvested. Now it started out with this layering of these different materials. No matter how deep you dig here, you'll come across an occasional worm. But no matter how deep you dig, it'll look like this. That's what it wound up being. And we let the worms do it. Now, here's the thing. Before we get started, I can really impress you. And that way you might pay attention.
It's always fun.
Oh, that's not good. Touch that.
Oh, that's nice.
Put some in my tea.
This is worm castings made by our method. Yeah, you'll want.
There's no worm tea in there. Make your own worm tea.
It's like going to the beach.
It's even better than that. Feel it's a little bit gooey, and that's what the worms do to it. Part of what they do to it.
Yep.
Now the question is, could you use this by itself? Here you missed out.
I didn't know if I had my hands in that before. Beautiful.
So, could you use this as is straight and grow things in it? Maybe so, I'm not sure how well that would work. Theoretically, it's topsoil.
Yeah.
Right, you can use it as a small percentage to really be a boon to whatever soil you do have. 10%, maybe 20%. And that rate goes more further, of course.
We put this on top of your garden.
Use it in the upper few inches. Work it in to the upper few inches. Well, you can do it by percentages. Usually, if you think in terms of shovel depth, called a spit. The shovel is 8 inches deep or something average. That's the depth of usually working. That's the way you don't most fertilize.
Feel it.
Oh, do it again.
That's the way your roots are going to be.
Right there.
And of course, that's where you start out. So you
That's 11. That's 11.
start. So you work your fertilizer.
That's some birds a lot to cover it.
It's deeper if you want to do it. But once you get past about 6 or 8 inches, the soil, as a rule, is starting to run out of oxygen. The microbes are not going to be as prolific and so forth. So you're trying to basically worry about that upper 6 to 8 inches. Now, I wanted Sean to be out here because he has had a role in making all of this and harvesting it and so forth. And then Iris, if we can have an interjection here from last week, Iris wanted to show you a couple of things. Why don't you come out over here, Iris? And she also wants to give a testimonial about our little garden back here. So,
I forgot to bring these last week. I just made a copy for everyone of the log sheets that I have, and you may want to rearrange some of the things on there. Yeah, you might want to call them comments, things like that. But and I also put.
you have to speak louder
Okay.
because of the rain.
And I also made a copy of one that I have, so you can just kind of look at it and see the information I put on here, how many I planted, and then when, and how many were potted, the plug size that were potted, and when. And it kind of gives me an idea from the time I planted the seeds when they were ready to be potted, can give you an idea. They're usually up in maybe 7 to 10 days. And
How many you wound up with?
Exactly. And then too, I can look and see, like this Romulus lettuce, I only got a few that terminated, and we never did quite figure out if it was the seed or if it had dried out what it was, but for some reason it just wouldn't grow. But that kind of gives you a history the following year to look at. Gives you an idea, looking back, what grew well, what didn't. And I also keep notes, just kind of on a scratch pad as I go along during the season. Something that really grew well, something that you want to grow again the next year. It gives you something to look back on the following year, because it's really hard to remember what grew.
Why don't I take half of them, give half of them to Sean, and you can pass them around to people.
Okay, and then I can make more and bring them if we need more, we can help you with it. And as far as the garden, I just wanted to tell you, Gary's garden last year, it is the soil. It really is, because last year we had a lot of customers come and say that it just wasn't a good year for gardening. Things just didn't grow. And as far as Gary's garden was concerned, we planted either 8 or 10 cucumber plants, and I don't remember how many. But we got almost 200 pounds of cucumbers.
Oh my goodness.
Out of this little plot here, cucumbers were only about a fourth of what we planted.
Right, they were just down the center, and we ended up donating almost 100 pounds to the food bank because we just couldn't sell them fast enough. And they just kind of sat there in the cool weather, but when the weather got hot, they just took off, and we couldn't keep up with them. There were so many of them.
Actually, it was Sean and Iris's garden.
But we didn't fertilize them. Once everything was planted, we didn't fertilize it.
But we did put number 1 in there, and we put worm castings, and we tilled in the leaves.
Right, before
If
planting.
you weren't here before, we're not going to be tilling the leaves in this year. The leaves are going to come off if it ever stops raining, and we're going to use them.
Too much organic.
They can release them, yes.
So you tilled the leaves in right before planting?
We tilled them in when we had an opportunity with a tractor here. Yeah, it would have been probably the fall before, or was it in the spring? When the
It
leaves got
was
tilled?
a little about right about now.
Okay, it was early in the spring then.
So the leaves breaking down didn't use up too much of the nutrients
Well,
in the soil, or is that a myth? I don't know. I don't understand.
no, it's not a
Totally
myth.
understand how that works.
If you put high carbohydrate, which they will tend to be when they go dry, they're going to lose most of their nitrogen in the process. It's something like wood. The microbes want the carbon that's in the woody material, or in the carbohydrates. They need that carbon for energy, but they also can't operate without nitrogen. And one of the things that the nitrogen does is it helps them build protein. And so if you have a lot of carbon and they're trying to process it, and they use up all the nitrogen then becomes limiting and they can't go any further. But what makes the difference is that in the meantime they're trying to use every bit of nitrogen that they can find in order to attack that, and if they can do it, then their population explodes. But what they're doing is they're taking all the nitrogen out of the soil for themselves, and it winds up in their bodies until they die and decompose, when some of the nitrogen is going to get released again. In the meantime, you're trying to get something started, something growing, and it can't find any nitrogen. And it can't wait until the nitrogen comes back.
I think the previous year we did put manure and leaves too.
Oh, there was manure in there?
A little bit. I mean,
So we didn't do it scientifically to keep track of what we did. Okay, so coming back to this then, we have all of the ingredients that will go into the next bed that we make. And by the way, worms can stand water. They don't really like it, but they can stand water. Standing water. So we'll start with topsoil, and topsoil is where, Sean?
it's over here.
Okay, just show them a shovel full of topsoil because they've probably never seen it before. That's actual soil. Okay, and then we're going to take we'll take the sand, which is in
So
this
it's just
bucket
random
here,
soil?
fine sand.
Yeah.
We'll put some of this in there. Probably not a whole lot.
We might have a
They,
little sand.
they need fine sand for the gizzards.
But it's hard to
They use it to grind up the other stuff that goes into their mouth and into their gut.
Where can we get that kind of sand?
Most
that
anywhere.
coarse sand?
You can probably buy it at Toys R Us or Ace Hardware or
So it's like a playground sand?
Yeah,
Or like
but this is fine. You don't want fine sand for making up your soil. You want fairly coarse sand, slightly smaller than a BB. The reason is that when it's this fine, and let's say you go out and buy some sandy loam, you're adding sand to sand, and it's so fine that instead of opening up holes, it's filling them in. Okay? So you want a particle that's big enough and ideally angular enough that it makes the other materials separate and then develops air gaps, because the roots need air. They need a certain amount without too much. It's the same way with the water, and the water won't be there if there isn't some holes. Actually, a certain amount of it will stick very tightly to mineral particles, even if it gets extremely dry. And at that point, the plants can't even remove the water. It's so powerfully absorbed to the particles. But remember I said that for creating air spaces, you want fairly large pore spaces, or holes. In other words, voids in the soil. For capturing water, you want small spaces. So anyway,
if we're using vermiculite and the perlite together, so
well,
doing the same thing.
I'm not real crazy about vermiculite, and as I mentioned in there, vermiculite has a tendency to soak up water, kind of like peat moss does, and soak up minerals. That's good quality, but it doesn't do a good job of aerating. Okay, and so your organic matter can do most of that, particularly peat moss can do that. Vermiculite is very expensive, and I think you can usually do without it. But just keep in mind that vermiculite and perlite are very different things and have very different properties for what they do in the soil. So you'll see these books that say, add so much perlite or vermiculite. Well, that's a mistake, because they do kind of opposite things.
The perlite does what the large sand particles
Yeah,
do?
it does. Yeah, it's sort of equivalent. Large sand particles, ideally slightly smaller than a BB. Okay, you get them much bigger than that, and it doesn't work very well. And they're comparable to, let's say, perlite might be this size in their physical effects, or pumice that might be even bigger. Have about the same effect, regardless of what size they are, within limits. So, in addition to the sand that we're going to add our mineral mix. This is it here, and per bed here we're probably going to use about 4 or 5 cups of this mineral mix, which has at least a dozen minerals, maybe 15 minerals, plus we put the microbes in here. May not be needed, but they're in there. The biosome, archaeobacteria, and the mycorrhiza.
Some trace elements too.
Well, yeah, the trace elements are part of the minerals. Okay. So there's like copper and zinc in here that we added, because our soils typically need some. And copper and zinc, maybe other things, you know that your body needs a certain amount, and boron, but you get too much and they'll make you sick, right? Or it's easy to kill you. So it's the same story with the soil and the critters in the soil. You have to have some, but not too much.
So it's 4 to 5 cups for the whole bed, or per layer?
Probably for this whole bed.
Okay.
Yeah.
How many cups per pound? So we know
with the minerals, a cup weighs about 3/4 of a pound. With the mixes that have a lot of organic, lighter material, a cup weighs about 1/2 pound, and that's on the bloom package. It says that. So we'll combine this with the sand in the soil. You wouldn't have to, but it's a good thing to do, is mix them in there.
So those 3 are layer number 1 then?
Yeah, that's going to be your layer number 1 is going to be the soil. Then we'll go to manure, which we have in this wheelbarrow.
Yeah.
Okay. This is a horse manure. One of the things I don't know is whether or not it's got a high amount of antibiotics in it. I had a chance to get it for free delivery, the whole thing, so I said, yeah, bring me some.
That's really dangerous for horses.
So, this may backfire. On the other hand, the worms might be able to decompose them, or there may not be much in there. We don't know.
Treat your worms right, they'll treat you right.
Yeah, that's right. Take them together. All right, then the next layer is going to be peat moss. And the peat moss is here? Yes. Okay. Ordinarily, peat moss doesn't look like this. This is from a local bog that when it was delivered was a big slimy, sloppy mess that I wasn't expecting. And it hardened and over time kind of caked, and then we had to break it up and run it through a screen, and that's why it looks like that. But that is local peat moss, which is probably several times more water absorbent than the stuff you buy at the nursery, or you buy in those plastic colored bales. And that turned out to be a problem for us. It held so much water, particularly in containers, the soil was essentially waterlogged. And if, however, you lightened it with perlite or pumice, it worked fine. But if we didn't do that, the plants just sat there because the roots were too wet, couldn't get oxygen, couldn't get the right amount of water, got too much water, and probably would go anaerobic, which means instead of having the friendly oxygen-breathing microbes that on the whole are the good guys, those kinds of conditions will breed the bad guys, which is the anaerobes, okay? And anaerobes, whenever you come across something really foul-smelling, usually it's something they did. And they did it by converting whatever it is, that's organic matter into some form that puts off obnoxious odors with sulfur and who knows what all. But they tend to be bad for you. They're bad for the roots. The roots are anyway suffering, and so these things proliferate and they just deliver the coup de grace to kill off the roots and the plant boughs.
You were saying something about peat moss or dark bark. There's this big controversy about over-harvesting peat moss and all that
and just to be real quick about it, that's a long story, and in my thinking it comes down to this is not any more ecologically justified, and the whole thing about peat moss is blown out of proportion because that information is coming out of England, where they long ago gobbled up all of their peat moss, and so now they're saying, hey, we don't have any left, therefore it's unsustainable. Well, in their situation, yeah. But if you go up to Alaska or some of the northern states, there's more peat moss and peat moss bogs than there is of anything else. There's millions of acres of it up there. And if we treat it right, it'll last a long, long time. It takes a long, long time to make it, but it'll last a long, long time. And in the meantime, maybe there's something that works as well. Maybe this dark bark will do the job. We're going to be experimenting with that because we did have problems with this.
What is dark bark?
Well, it's just well-rotted bark. And it probably comes from lumber yards. Not where you buy lumber, but
mills
and so forth, where it gets spilled on the ground and they drive over it. It's an impure world, folks. It's really hard to be pure. Ask, what was the flag's name? It's hard being green, it's hard being pure. So then the next layer is the vegetation. And there we're going to be using grass clippings, which Sean went out and got us some grass clippings, in case you've never seen grass clippings. So for some reason, supposedly you want those to dry out somewhat. You want to get them, remember now, as far as the worm is concerned, he doesn't really like them in that green, raw state. He wants them semi-decomposed, and for other reasons you're supposed to allow these to turn a little brown. Now, if you leave them in a layer, then they turn mushy and black and stinky because they shrink down, they squeeze out the air, the anaerobes take over, you get a slimy mess, you get a foul odor, but you use them anyway, right? If you got long clippings. And the other thing that's often abundant is leaves. So we're going to take the leaves off of here. It came from around our yard. they're going to get mixed into this vegetation layer. Then we're going to take our kitchen scraps, which is, that's somewhat like our kitchen scraps. We've got more. And that's going to be part of the vegetation layer. And then we're going to use coffee grounds, which is here. These were left over from last year. They're a good nitrogen source, and in spite of the fact that they're brown, they're considered a green material. So like when you make compost, you're supposed to use browns and greens. That brown is green because it's got a good nitrogen source. And then you can use ground up cardboard, which I was planning to do and make lots of with that thing until it broke down and it's no longer usable. The shredder. So that's all the ingredients that go into it. Then when you get to the top, you might want to first top it off with a little more soil, then put your chicken feed with some lime in it. And lime is a good thing.
Tell me about lime. What's the difference between them?
There's all kinds of limes, some of which are caustic, some of which are very healthy. A major part of the Earth's surface is limestone, okay? And in some ways, it sometimes contributes to making really rich, lush growth because it's there and it's accessible. But you can overdo lime, and the lime that is best is calcium carbonate in most cases. So it's simply calcium, carbon, and oxygen. And of course it has a pH effect, makes things more alkaline. But then there's dolomite, and the difference there is that dolomite is a high magnesium lime. I've forgotten what it is, maybe 40% magnesium, something like that. In the other class I mentioned that calcium has the effect of loosening soil, and particularly clay soils, and magnesium has the effect of tightening soil. So if you wanted to tighten the clay soil, maybe dolomite's the thing to go with. If you wanted to tighten the sandy soil, you might want to use a dolomite. If you want to loosen a clay soil, you use lime. Lime and organic matter, for all practical purposes, in terms of natural materials, are the two key things you use to loosen clay. And as I think might have been obvious from what I was saying about clay and humus being the really important components in a soil, a clay soil, can be something that you curse, but you can turn it into an advantage, and it can be something that is, you'll be glad you had if you can loosen it up, and if it turns out it needs mineralizing because it holds those minerals, and when you get the two together, the humus and the clay, ultimately you wind up with just the right composition. You could put on some coarse sand if you could find it, but to make a big difference you'd have to bring in a dump truck load or more, right? So it turns out not to be very sensible or economic, probably, unless you happen to have a ready source of it. So those three things will help you loosen up clay. And the fourth thing is, guess what? Earthworms. Okay?
Question
you can get them going, man. You can turn that into choice growing soil in fairly short order.
Yes. Regarding the changing your clay soil, a method. Is there a preferred method? As far as, I've heard of people taking out plugs, filling, tilling, just putting it on top.
Tilling won't get you anywhere unless you work in organic matter and lime.
Right. That's what I'm saying. As you're applying these things, what's
and you could also bring in topsoil and spread some topsoil and then till the whole thing together.
You let it sit for a while,
You're trying to get what a worm would like, right?
Right.
You got some clay, you got maybe some sand, you got some organic matter, maybe it's aged manure, possibly peat moss, other vegetation, worms, bacteria, all of that stuff. You turn it into a soup, and if you did it right and you got the mineral balance in there, use a soil test to find out for sure. then you can grow, as I've said, almost anything very well. You could tweak it for different types of crops and plants and so forth, but it'll grow very well without doing that. I can just about guarantee that.
If you get your soil squared away, will worms come to it?
In a sense, yes. Yeah. But they also have to have something to eat. And so, in a sense, if you square it away, you kind of use up all the existing feed. And so you do want to supply them some additional feed from time to time. And over time, your organic matter and your humus level will tend to go down. The more you work the soil, it burns it up, and there is a natural level for any given climate and region that organic matter will tend to settle out. If you try putting too much on, before long it'll settle out to where it was to begin with anyway. So why waste your time? Yes.
30 years ago I bought property down here and there's nothing on it. Well, I started gardening. First year of gardening was okay, and then it needed more, obviously. And so I was reading catalogs and saw the advertisement for buy a box of worms for your compost to inoculate it. And I thought, well, I don't have any money, but I've got compost, I'll just start making it. The worms came. They just started, and I put it underneath a big fir tree to help protect it from the snow and rain and kind of keep it a little warmer. And just started throwing on whatever I had, and the worms came. And I want to emphasize cardboard, because I line my compost with cardboard. And in the cold weather and in the real hot weather, I find the worms crawl into the corrugations, so you don't need to shred it. They crawl right in there and they just snuggle right in, and they get really long and happy.
Wow. Yes and no, you don't need to. It kind of depends on how much of a hurry you're in. If you take this stuff here and you layer it in, turn the worms loose, as long as the temperatures are okay, 4 months later you come back, it'll be like that.
Right, right. The finer the material, the faster the process.
If you chew it all up and make it fine and intermix it, you come back in 2 months, it may be ready. 3 months, it'll almost certainly be ready. So you will have shaved a month off of that.
Right.
And if you're in the business that we think we're in, of trying to produce this stuff, you know, on a big scale, a month can make a big difference.
Yes, I noticed it, well, in the winter, I leave the pieces large, because I've got all winter, and I want the worms to, and then layer it in there so that more air, extra insulation. In the summer, I do stand there and shred up the cardboard into smaller pieces.
But you need to realize that rotting and decomposition is about 90% done by microbes and worms and perhaps other critters. If it weren't for them, we'd be wading around in debris. So they're constantly recycling that.
Do you need a barrier on the bottom of this, or just could it be on soil?
We have actually this fabric was on the bottom because we wanted to keep molds out for one thing. Ideally, you wouldn't want it. You could put in galvanized screen to keep the molds out. Well, if you were using this as a growing bed, you'd want the plants to go as deep as they can, and if you got this, they can't. Right? So that they could probably put the fine roots down through a screen. Probably in the case of redworms anyway, they won't tend to try to go down under and out of your bin. So you don't need to worry about the worms. If conditions, however, get bad, they will try to crawl out through the top and leave. And once all of this gets thoroughly processed, like that, there are a few worms in there, but basically there's nothing left to eat, because it's all been eaten by something. It's been turned into a form that the worm can't use. The plants can, but the worm can't.
Does the worm die in there?
It'll die. If you leave it long enough, it runs out of food, it dies.
So do you sift out the worms and move them to the next
Well,
bed?
what you do is you come back in 4 months and you skim off the upper 6 inches and you put it out on a table and you make little cone piles, and you go through it in steps, and the worms continually move to the bottom, and eventually you harvest them. You can do what you want with them, put them back in the next bin, go fishing, sell them, feed them to your chickens, but you save back enough to start the next bin.
How long do they live?
How long will they live? I guess, you know, that's disputed. Some books think a couple of years, some think 15 years. Yeah. So I don't know the answer. It might be difficult. You'd probably have to tag them and give them names.
Now you're using red worms. She used whatever showed up.
Yeah.
Is there?
Well, the red worms will be out there, and the earthworms will be out there in more or less sparse numbers. You create the conditions, they'll find it. If it's what they like, they'll proliferate. Okay? But they won't do it without that. You can't just take them out in your garden, throw them out there, and expect you're going to come back next month and there's going to be worms all over the place. They'll die. They'll be gone.
How many worms do you put in one of these?
You know, I don't remember what we used. Probably this many. The more you put in, the faster it's going to work.
Will wood stove ashes work for lime?
Wood stove ashes are like a lime. They have a lot of potassium carbonate as opposed to calcium carbonate. In general, you want to stay away from a lot of potassium, particularly in the food you eat. And that's the problem with living in the Northwest, because for some reason we don't get enough calcium, and the plants that live here are able to live, or maybe most anywhere, native plants are able to live on potassium, but potassium beyond a certain point is not particularly good for us, and it's not good for other things. And this is why, compared to, let's say, the prairies of Nebraska or Kansas or something like that, which once supported huge populations of buffalo and other things, until we started feeding them more or less, you don't find much in the way of deer or elk, you know, on a per acre basis in this climate, because the food isn't nearly as rich as back in the Midwest. The ground isn't as rich. So, I forgot the original question, but wood ashes contain a lot of potassium. And so, if you try to use them to neutralize soil or to replace calcium, they have calcium, but the general recommendation is to use about half as much, because you can't avoid also putting the potassium on and you get too much potassium in there. And when they say when you have wood ashes, keep them under cover, don't let them get wet, because the potassium leaches out pretty fast. But I would think that the trees and so forth pick it up and they build it into their wood, so that their wood is fairly high in potassium, but also calcium, and all sorts of trace minerals as well. Trees will store trace minerals, not a lot of them, but when you burn them, that part does not go off the smoke. Okay? Those are minerals. Minerals you can't burn very well. So the organic matter gets burned, it goes back to where it came from, which is the air. The minerals wind up being not burnable. That's in your fireplace. Those, you know, want to go back to the earth, and the best thing you can do with wood ashes is to spread them out in the forest. You're not going to do any harm. But use lime in preference to wood ashes. You can run wood ashes through the compost pile, you know. But again, I suppose you can overdo that.
Okay. But in these worm beds, was it not a good idea?
You could use some, but you'd want to be sparing, I would think, with wood ashes. So what have I left out?
The only thing I was thinking is, we found with the worm bins in the summer, especially being in the hoop house, it gets really, really hot. They were drying out very fast. We tried putting burlap on top of the pile and it was still drying out. So we just laid those large sheets of cardboard on there, and it really helps to keep the moisture and it keeps it cool for them. We still have to water them when it's really hot every day, but the cardboard really helps on the top.
Yeah, well, you have to have it because, well, they need a dark environment. I mean, they'll live down deeper if it's exposed to sunlight. This year I hope we'll get around to putting shade cloth on this, and we roll the sides up, but it still gets too hot. And that's a problem. I came up with this plan to keep them out of the elements for the most part. Put these bins in here. And I wanted to run them this way, but that didn't work out. Couldn't space them right. So I wound up doing this, right? Which in a sense uses a lot more blocks, but also makes it a lot more manageable in that you're dealing with smaller units over time that are more manageable.
You put wood along the top here, was that for?
Well, maybe not necessary. We did it on our garden bed so that you have a place to sit down.
Okay.
And it's nice.
And so you make them something close to 4 feet wide. As it turns out, the way you lay these blocks, it winds up being 40 inches on the inside from here to there. And that's just about an optimum size for you to be able, if you're using it as a garden, and we do have some over there that we've used for gardening, you can sit here or somewhere around here and reach any point in the bed without having to get into it, without having to stoop over, and so forth. So it has a lot of advantages. And then it also helps in part because these boards kind of help help it, stay in place, and then the weight of whatever you put in here probably somewhat pushes against it on the inside.
So you use that same deal for a raised bed garden?
Yeah, and we may look at that next week because we're going to be talking about making soils for various purposes, including raised beds. And the thing about getting ahead of us here, the thing about a raised bed is, particularly in a situation where you just don't have a good workable garden, right? Your soil is rocky, it's clay, it's muddy, it's what have you, it's thin, problems. With a raised bed, what you do is you rise above it, okay? and you fill the thing while you're at it, you fill it with the most optimum, nice, workable soil that you could possibly put in it. And that has all kinds of additional benefits. And people look at that and say, well, that's expensive. Well, how much could I pay you per hour to weed? Right? So it largely does away with the weeding problem. You get a weed in here, you go like this. Tweak, and you're done with the weed problem.
So would it work to put grow stuff in that worm bed once it's done? Or is that
well, that was the question I asked before, which is, can you grow good crops in that particular worm castings? I don't really know. We probably should experiment with straight worm castings. What is the effect? We do know that the best combination is the minerals and the organic matter. Not compost, not straight minerals, but the combination. It's the synergy, right? And the worms take the synergy to a new level because it wouldn't happen on its own.
It looks like your soil would be a lot higher percent of organics.
It is.
Because you're saying you should have 5 to 10%.
Right.
And
It has very high,
mostly organic.
a very high percentage of organics compared to what your soil would have to have, or maybe even what is ideal. But one of the things that counters that is we're adding extra minerals, because one of the effects of putting too much organic matter in your soil, whether it's inactive biologically or active biologically, is that it disperses the trace minerals, okay? Because the organic matter itself can only hold so much trace minerals. And the more you pour on and work into your soil, the more you're diluting whatever the minerals were in your garden, right? So if we add minerals and offset that, we have offset a big part of the problem with overdosing with organic matter.
Yeah.
Right? But still, it's the combination, and that's one of the reasons why we go to soil in our worm castings mixes, which almost nobody else does, and which a lot of the authorities will say, oh, you know, stay away from soil. After all, it's dirty. And it's got germs, right? Germs. Oh, germs. Well, germs are what make it all go round for us.
Would you, is there a difference between glacial rock dust and azomite like in putting into this?
Well, we talked about that earlier, right? Was that you that raised that question?
You said that the azomite had more clay in it.
Well, the glacial rock dust is derived from gravel, ground up gravel, whether the glacier did it or they do it with machinery. It's a byproduct of making cement, actually. Is one of the sources. So it's ground up gravel. Azomite is a natural deposit that is clay-like in that it's basically a montmorillonite clay, which has these great properties for holding on to trace minerals, right? So you're using the straight thing when you're using azomite. You might be grinding it, sifting it, and bagging it, and so forth. But with the glacial rock dust, you're starting with rocks.
Yeah.
Not a clay deposit, but the rocks themselves. And it's the mixture of rocks, all different kinds of rocks, because as the glacier is moving down the mountain, and it carved out Puget Sound, and it carved out Black Lake, it's pushing all of these rocks, not only in front of it, but along the sides, and anything that happens to be under it is getting pulverized, right? And it's being slowly moved, and eventually, because the temperature changes, the glacier starts moving back. And when it moves back, the rocks don't go with it. So they're down here, and the ground up stuff is down here. And over time, particularly in agriculture, we deplete that. And so one of the nice things about global climate change, if it results in glaciers, if you stick around long enough, it'll remineralize the ground here. At one point, there were glaciers, you know, like a couple 100 feet high right here. 14,000 years ago. Went through here, got as far as Rochester, didn't like it. Beyond Rochester, it stopped, and then backed up. Created a huge lake down here in the Centralia vicinity. That lake broke through and turned right and went to the ocean. I don't know if it carved out the Chehalis River, but this was all a huge lake at one point when the glacier retreated. Fascinating stuff.
See, you've alluded a couple times throughout your speech, your 3 classes, to you know, millions and millions of years and all these things being developed. But then you've also at certain times you've said you were so amazed at what you were looking at that you said it's by design. And I've caught these 2 different views, and it's just put this question in my head. Okay, where exactly does Mr. Klein come from?
Well, I don't know. I'm a biologist. I believe definitely that evolution is a reality. Okay, I don't think there's any way to really deny it if you look into it. But is there some kind of a cosmic plan behind it? Does this cosmic planner have a personality? You know? Did it all happen just by coincidence and accident? Kind of hard to see how it could all have happened by coincidence and accident. But it's not impossible. It could be. And yeah, I guess that's enough said.
Just curious, because I'm going, over here, over here.
Yeah. They aren't necessarily mutually exclusive, but they might be. Alrighty, where are we on time? I took my watch. Oh, I got it. Pardon?
12:08.
She has a question.
One little question. How deep are the layers?
6 inches. 6 inches. It doesn't.
Take 3 inches each.
It maybe doesn't matter a great deal.
3.
Yeah. So if they didn't sink, it would take 8 layers, 6 inches deep, 1, 2, 3, 4, 1, 2, 3, 4, to fill this bin. And they do sink. And of course, as the worms process them and make the material finer and finer, they're going to tend to sink as well. The same thing happens in a well-made compost pile. You make, and we're not doing composting in this series because we don't have the time to go into the whole thing. And like I said, I think you're really better off making castings anyway. But you build a compost bin ideally all in one day, and you take a circle of wire, maybe so big around, and you layer it in very much the same fashion. We call it the SPAM method. So the SPAM stands for soil, plant, animal, and mineral matter. Well, basically that's what you're looking at here. Alright? And you build it until you get it up chest high or so. And if you've done it right, you've got everything layered in there nicely, you got the moisture right and so forth, you come back the next day and it's dropped almost 50%. Maybe 40%. You come back, where did all that go?
Thank you for watching. See you later, YouTube. Bye, Diego. You're recording. This is the Zoom.
So as far as the trace minerals,
Basically,
or as far as the trace minerals, do you just kind of recommend looking for signs, or rather
You
than
wanna get the-
specifically testing them, or kind of expensive?
The
like
shot
that?
behind him and him in there.
So you just put a general.
That's